Hello everybody. In this video, we're going to look at nested loops, which are loops inside of loops. All right, let's get going. So here is my starter code. Because Replit changed the business model, I'm going to switch to PyCharm Community Edition for my IDE. So first, I'll copy the name of my Replit file by double-clicking it and hitting Control-C to copy. I'll go into Replit, and in my project folder, I'm going to right-click, New, Python file, and then I'm going to paste in the name of my file, replace your name here, type Enter, and there's my Python file. Now I'm going to copy over my instructions and starter code. So it's not going to let me do Control A this time. So I need to select the whole thing, then do a Control C, go into my PyCharm, hit Control V, and there I go. I don't need to change the .replit file for PyCharm. If I do a quick test, I right click, click Run, and I see I'm running this file. So here we go with problem one. Problem one, make a function called loop1 with no parameters or return. So this should be automatic by now. Def function name, which is loop1, parentheses, colon. And with no parameters and no returns, that's all we need. So now I want to print the following 6 stars, but with a for loop. So what that means is I cannot print it all out at once. So I can't do something like this. I also can't do something where I'm making a fake loop. So for example, this is not a real loop. I'm really only looping one time. And if I'm repeating once, I really don't need that loop. So this is not what we're looking for. So what are we going to do? Well, what we're going to do is build this picture, these 6 stars, block by block. So I'll start with an empty string, and then I'll loop. And how would that work? Well, you can see that this picture can be thought of as a repeating pattern. The pattern is a star and a space, and that repeats 6 times. So if I'm going to repeat something 6 times, I can code that up now with a for in range 6 that will repeat 6 times. And inside of this loop, I'll add a star and the space to the string that I'm growing. So if I translate that into code, I have something that looks like this. So this code repeats 6 times, and each of those 6 times, I'm adding a star and a space to my string. At the very end, I'll print out my string. How do I test this out? I call the function. And how do I call a function? It's going to be function name, parentheses. So let's try. Well, that didn't work. And now I see that I made a mistake. And my mistake was this. I'm trying to grow out this picture each time. But what I did instead was overwrite it each time. So to grow it out, I need to do something like this. So again, I'm doing the right side first. It takes whatever picture was before. It adds the star. It adds the space. And then it overwrites what picture it is. So let's try this one more time. And this one looks good. A quick note about this underline. The underline is an unused variable, which means I'm not going to use it later. I'm not going to print it. I'm not going to do math to it. I'm not going to use it for anything. I could have used an I or a J, but by using the underline, I'm making it crystal clear that I'm not using the variable for anything. So I'm using it for clarity reasons. Problem 2, I'm going to make a function called loop2 with no parameters or returns. So again, def function name, parentheses, colon. So this time, there are no repeating patterns. But I'm going to use my concept from before where I start with an empty string and grow it out. This is my empty string, but what do I loop? This time, I'll take advantage of the fact that when I have something like for variable in range, the variable is an actual variable and it stands for the number that I'm on. You did this in a mini lab and we're going to do it here. The first time I did this loop, I didn't use the variable, so I used an underscore, but this time I will. And you know that I can loop between the numbers 4 and 11 with something like this. Remember, the first number is inclusive and the second number is exclusive. So putting it all together inside my loop, I do something like this. And I'll try to print it at the end. Remember, I have to call my function with function name, parentheses, but no colon. But when I do that, I get an error. So this is a classic error. And why is that? It's because I cannot add integers and strings with a plus. The I is an integer. The space is a string, and for me to join them together or concatenate them, I need to cast an integer to a string. So now I have a string version of the integer I and a string version of a space, and now I can concatenate them together. So I'll run the code, and I get what we're looking for. Again, this error right here is a classic error that you'll want to avoid. And with that, we're done with problem 2. So now let's start on problem 3. I'm making a function called loop3. So once again, def function name, parentheses, colon. So this one looks very much like problem 2 in that the numbers are increasing and I'm printing out the variables, the counting variables. So if I do what I know from problem 2, I'll write out code that looks like this. I'll change this number range from 1 to 12, call the function, and when I run it, they're a little bit different. And how are they different? The expected printout has every other number as a star. Every other number is a star. So this brings us to a classic algorithm in Python, which is the test for even or odd numbers. If you remember the mod from earlier when we did math, the mod gives the remainder whenever you divide two numbers. If you divide any even number by 2, the remainder is 0. And if you divide any odd number by 2, the remainder is 1. So we have two scenarios. And when we have two scenarios in Python, we use an if and an else. So let's put that in now. And we test to see if I is even. And if it is, we print a star. So the test for even is that the remainder, when you divide by 2, is equal to 0. And in this one, we're printing the star. And when I is odd, we are going to print the variable I. So we put all that together, try it out, and now we're done with problem 3. For problem 4, we're going to make a 6 by 6 square using double loops. Let me just comment out this old code first. Problem 4, it wants us to write a function called loop4. So once again, def, function name, parentheses, colon. And this one is going to look very similar to problem 1, at least at first. So we'll use the solution for problem 1 and run it. And when I do, I get a row of 6 stars, which kind of looks like this first part, but I really want 6 rows of 6 stars. So how do I do that? If we think of this chunk of code right here as one chunk, so in our minds, we're going to call it row. And then if we repeat the row 6 times, we'll create the picture we're looking for. So to do that, we'll create one more loop. We'll call this the outer loop because it's on the outside. And it's going to go 6 times. And the code for the row is going to be inside of this loop. So when we run it, we get our 6 by 6 squares. Now there is another way to do this code, which is at the same time better, but also at the same time a little bit harder to understand, in my opinion. So instead of printing out your picture after each row and resetting it after each row, I'm going to print it out only once at the very end. So I can create this string, empty string at the very, very beginning. I'll add to this string each time going across right here. And when I'm done, I'll add what's called a new line, the /n, the \n, which will print out going to the next line. And then at the very, very end, I'll print it out. And when I run this, I get pretty much the same picture as before, but in a different way. The advantage of this style is fewer prints. I only have one print at the very, very end. So printing here is pretty easy, but if I were printing something, for real, like a 3D printer, and I have to warm up the printer and clean the printer every time I have to print something, then it's going to be better just to print once. The other advantage of this style is that I can hold it until the very end. So if I have any corrections or changes to make, I can make those changes. If I print it after each line, it's printed already and I can't change it once I print it. The disadvantage for me is that this is a little bit harder to understand and a little bit more disconnected from the problems that I did before. But both are okay. Just pick the one that's better for you. So now we're at problem 5. In 5, I need to make a function loop 5. So again, def, function name, parentheses, colon. And this one is going to be similar to number 2 and to number 4. Similar to number 2 in that we're printing a sequence of numbers. So let me reuse the code for number 2. And to test it out, I need to call the function with function name parentheses. And the number range will be a little bit different than number 2. I need to change this from 2 to 8. The first number is inclusive and the second number is exclusive. Okay, so now my first row matches my target. And now we are repeating this printout 6 times, which is just like problem 4. And by that, I mean I'll take this code here, I'll think of it as just one chunk of code, and I'll repeat that code 6 times. So, and let's try it out. And here's my answer for number 5. Number 6. And number 6 is going to be similar to number 5. So if we look at our pattern and we look at the second part of the pattern, we see -1, -2, -3, -4, -5, -6. So hopefully you can see it's almost exactly the same as what we just did and almost the same as number 2. So I'm going to reuse the first part of number 5. But before I do that, I'm going to make my function first. Def, function name, parentheses, colon. I'll reuse problem 5, which gave me 2, 3, 4, 5, 6, 7, and then I'll change it later. I need to call the function to test it. And when I do, I see my number range is wrong. So let me fix that number range. So now I have the 1, 2, 3, 4, 5, 6. And what I need is the -1, -2, -3, and so on and so forth. So I need the dash, which never changes and is constant. And that means, because it's constant, I don't need a variable to print it. I can just print it straight away. So I will go ahead and add that dash and print it out one more time. So it looks good so far. And if you look at it a little bit more closely, you'll see this pattern -1, -2, -3, -4 repeats every line. So once again, we can reuse what we did in problem 5 and print it out 6 times. And so far, so good. But now we're at a place where the code is different from what we did in number 5. And if you look at the pattern we're trying to get, let's look at this first number here. And you see, as we go down, it changes. So that means we need a variable. When things change, we need variables. Well, what variable? Well, if we make this outer loop a variable, let's print that out just so we can see what happens. So now that's very, very close to what we want. This first number here is the outer loop. And if we adjust this range, we get what we're looking for. So we got a little bit lucky, truthfully, that it just happened to work out. But what you want to remember is this. The numbers are increasing left to right. It's the variable in the inner loop. And if the numbers are increasing up and down, it's the variable in the outer loop. And that's the kind of trends you want to look for. How do the variables change as you go either up or down or left and right? So now let's do number 7. Again, we need to make a function loop 7. And in some ways, this one is going to be similar to number 5. Except the number range is different. So let's start with number 5 and work from there. And we see that our number range is a little bit off, but we can fix that. So we're part way there. But we have too many numbers here. The 2, 3, 4, 5, 6, the 3, 4, 5, 6, the 4, 5, 6, the 5, 6, the 6. We need to get rid of those. So how do we do that? Here's where we will use the concepts of number 6 to help. The inner loop is going left and right, and the outer loop will increase as we go up and down. Again, the inner loop increases as we go left and right. So what we see is the first time this inner loop goes, it goes once. The second time this inner loop goes, it goes twice. The third time, it goes 3 times, and so on and so on and so on. And when things change, we need to use a variable instead of using these hard-coded numbers right here. So we'll use a variable. And each time we go through this inner loop, we're going to increase that variable by 1. So let's make that variable now. We'll start it off at 2. We'll have it go from 1 to counter. Each time I go through that inner loop. So let's try this out. Oh, you know what? I made a mistake. This counter should be on the outside. If I put it on the inside, it'll reset back to 2 every single time. What I want to do is start it off at 2. And then every time I do this inner loop, which is those numbers going left to right, I want it to increase by 1. So let's try this out. And when we do that, it works. The key here is I'm putting a variable inside of this range. Why? Because this range changes every time. So let's do number 8 now. Number 8 looks just like number 7, but it also looks like number 3. So let me start off by copying over number 7. And then, once again, we realize that what I print out changes if I have an even number or an odd number. So in this case, the even numbers are printed out, and the odd numbers are going to be stars. So I have 2 scenarios. When I have 2 scenarios, I'm going to use an if and an else. So I'm going to check to see if the number is even.
And if I is even, I'll print out the I.
And if the number is odd, I'm printing a star. So let's try this out. And there we have it. We matched the picture. All right, so that's pretty much it. Hope that was useful to you. And if it was, please give this video a like and subscribe to my channel. I'll see you next time.